Combustion technology needs to take care of turn down the efficiency at which it is going to operate, the emissions. It can help to get the best possible results.
So this technology gives the customer long-term flexibility because every fuel is different. There has to be a system which adapts to it.
The biomass follows the crude oil prices.
Industries tend to oversize the boilers. It has a direct impact on the efficiency.
Welcome to yet another episode of podcast by Forbes Marshall, FM Energize. And today's topic is fuels and combustion technologies. With me today, Mr. Anshul Deoras, who heads the Customized Energy Solution Group for us in Forbes Marshall. And I myself, Arun Niphadkar, I take care of the package energy solutions for Forbes Marshall and under the joint venture of Forbes Vyncke. It's been last one decade that we are seeing that there is a lot of fluctuation in the energy source which is available for the different areas like the domestic market, the transportation industry, as well as the industrial industry. And what we are seeing that there has been a lot of change in terms of the cost of fuel as well as the sustainability or the availability of the fuel, which is going to be a problem in near future. Considering all these aspects, what we realize is that it's very important that while we are choosing a fuel for a particular energy requirement, one has to get into a deep diving of each and every point in terms of what kind of costs it's going to have and what kind of sustainability we can get from that particular fuel. So, Anshul, looking at the current scenario, what is your opinion on what are the areas where one should look for while it is selecting a particular fuel for a particular kind of energy requirement which a particular plant has?
Thanks, Arun, for the kind introduction. Uh, so energy needs today of industries are increasingly becoming complex and challenge, and they face various challenges while they are trying to select what kind of energies or what kind of fuel that they want to select. Starting with, it's not only driven by the cost of the fuel or the cost of the energy, but it has many other things like sustainability or what they're doing for the environment. A few challenges that come to my mind while we look at these, or common challenges while we come across when we discuss with customers, are: one is, what is the cost of my energy with respect to the cost of the end product itself, wherein there is a spectrum of customers where we look at that it could vary from very minor impact on the overall product cost, but a heavy impact also, which could be right from 5% to 50-60% of the energy cost could be a part of the product cost. So that's one very important aspect of the fuels that are being used. The second part is, where is in which geography they are located, what are the options they have, whether they are located in an area which has only oil and gas as an option, or look at other options like biomass or all of these things. So that also plays a very important role. What is the capex involved into it versus what is the operational cost? While we see that an oil-fired boiler or a gas-fired boiler could be lower on capex, but it could be very high on operation cost, and vice versa for other things. And at the end of it, what by using any of these energy fuels, what is the challenge in terms of the emissions to the environment? What are the challenges in terms of the safeties and the overall health and other factors that creep into? So I think it's a mix of many challenges that any industry has to look at, and the decisions have to be a balanced one considering all of these facts.
And also, we have seen there has been a lot of non-conventional source of energy, which is getting picking the required, energy source, one of the energy source for the requirement of energy in the industry. So, what kind of scenarios we should look at when it comes to energy source like hydrogen? If you look at the energy source like electric boilers, so how they can be looked at as the source for energy for the plant? What is your opinion on that?
It's a very interesting times that we are into, as when we look at the industries. There are many research and development activities that are happening into alternate fuels, because we look at, there is a fossil fuel that is available, there are biomass fuels that are available, and then there is a emerging avenue of alternate fuels, which could be hydrogen or which could be electricity. Now, what has pushed us to do this research into these avenues? Because we know that at some point in time there is a limited resource of fossil fuels, there's a limited resource of biomass, and very soon it could be running into shortages. So it's important that the research is done in these areas as well. While the researchers today are into very nascent stages, there is a lot to be done in these. Most of the bulk of our customers are still burning the conventional fuels which are within oil and gas or biomass as fuels, and that's where most of the challenges and the work related things happen as of today. um, we still needs to be seen how things go in terms of the alternate fuels that are available, because the infrastructure to support that, the what are the challenges when you use it, and then what is the environmental impact of that, still needs to be seen and arrived upon. What we normally see is, with all these options available, customers tend to get confused on whether I can use this or a B fuel or a C fuel. And I think it's very important to understand the pros and cons of each, where we stand in terms of what's available in the market today, and how is it in terms of the scalability.
So specifically, if you talk of an electric boiler, what we have seen is a electric boiler is becoming more popular globally. However, in India, the scenario is not the same. What is your understanding
So,
on that?
so India is still emerging as a part of getting into electricity generation on renewable sources like wind or solar. We are not as developed as the Western countries would be, or Europe would be, in terms of the renewable dependence on the power generation by renewable. If we go by the map of the country, most of the wind or the solar generation happens on the western side of the country, which is more where you get more wind and more uh, solar energy. But a lot needs to be done. There are challenges when it comes to transmission. So now the point number one to select an electrical boiler, if the customer has to look at it, is what is his cost of electricity. If it's coming from a renewable source and is cheaper, it would make sense for the customer to explore that option. Now, having said that, the limitation today is there are not many options available for larger capacity boilers in the market. These requirements can still be met, but the capacities available are very small, say a 1 ton boiler or a 2 ton boiler. But anything beyond that is not yet available as of today. So I think it's definitely a area which the OEMs like us can work upon and explore these opportunities and be there with the customers to offer them the solutions.
Exactly. So with a non-conventional source, we are seeing that still the technologies are at early stage, and people are developing the technologies, at least in India, to ensure that we can have hydrogen and electric power also seen as an option for energy requirements. But then again, coming back to the conventional source, which, as you rightly said, one of them being oil and gas, and the other one being the biomass as one of the major contributor to the energy requirements today in India. How do you see these conventional energy sources can be worked on while you are selecting a particular energy source, and what are the criteria or what are the things which can be seen as the major uh, differentiators for selecting a particular fuel? Because it's very very important that while selecting a fuel, it's not only that the fuel has its own calorific value, the cost implications, but it also has to be sustainable. So on that angle, how do you see customers looking at it while selecting a particular fuel in the conventional source?
So I'll answer it in two parts. I'll take the oil and gas first, and then go to the other part in terms of the other options that we have. If you look at oil and gas, it's been a traditional fuel that most of the industries in India started using, and for many many years they were using that. Uh, Over the last 10 years, what we see is there has been a lot of turbulence into the global market, and hence the petroleum prices have got impacted and they have been erratic, and which has directly impacted the energy cost. Now, what was the reason why customers used to go for a oil fired boiler or a gas fired boiler? I think some qualitative benefits in terms of having a compact space, simpler layouts, easy operations was something that was being done. However, if you look at the cost of energy, there's a difference of at least 3 times to 4 times when you compare the
Oil and
per
gas.
1,000 kilocalories of heat generation. So there is a substantial impact. So that directly impacts the energy cost as a overall part of the product. So it could be as high as 50-60% in many cases. Now, there are industries who still continue to use oil and gas. There are many reasons to it. One, if the product itself is a high value product and a high margin product, it doesn't impact the energy values as such. However, if you are in a market wherein the margins on the product itself are very low, uh, one has to look at every small bit of the component that goes into making that product, and the usage of either oil or a natural gas is purely dependent on what we are trying to do. If you look at oil, there is a lot of SOx and NOx emissions that go into the atmosphere, so they are not good for our environmental access itself. And secondly, it also goes into a limited resources, wherein now customers are looking at alternate fuels that are available, which take them from a conventional fossil fuel to a biomass based fuel.
So, looking at the last one decade, which we can see, we have realized that even the crude oil prices are having a lot of fluctuations. The crude oil prices are also shown that at a point it goes, to the levels of 30 rupees per liter, and it goes as high as 50, 60 rupees per liter also. In the same way, the biomass follows the crude oil prices. And what we have seen is over the last 10 years, we have seen a three times increase in the cost of briquettes. So this all leads to a simple thing that when someone is using a fuel for their energy needs, it's important that the fuel firing, which is the combustion system, makes the prime importance in terms of what should be the technology for a particular fuel which is best suited. So on this, I think there has been a uh, uh, lot of innovation which has happened, which has led to newer technologies coming in the market, and there has been changes in the way people are looking at the boilers or the thermal fluid heaters, which are the major energy sources. So which are the areas where one should look for when he is choosing a particular energy source, which we discussed of? But what technology is best suited? How do we define that part? That's also very important, because as we know the cost of fuel is going high, it's important that we should utilize it with the best possible or a efficient way.
Yeah. So again, we there are various technologies that are available. A few developed, a few under development. So improvements are something that always keep on happening. If we take the example of oil and gas, what's very important is what is the overall response of a technology that we select with respect to the process variations that happen. It's very important to look at that, because the boiler has to cater to the process and not the other way around. The process has a higher demand, but the boiler is not able to do it. It will create an imbalance and directly impact the capex cost and the operation cost also. More often than not, we've seen that industries tend to oversize the boilers. When you oversize anything, it has a direct impact on the efficiency, it has a direct impact on the operational cost. While we are selecting a technology for, say, burning oil or for gas, one thing that's very important is what is the turn down that we are getting. By turn down, what I mean is what is the lowest load at which the burner still keeps firing, and there is no substantial or significant loss of energy that could happen. Um, so there have been burners which were earlier mechanically regulated, then there were a combination of mechanical plus electronic, and then there are these burners which are completely electronically controlled, wherein there are no mechanical linkages, so which could get in the errors of operation. So the moment you have a electronically controlled burner, you have a PLC held operation, which impacts a repeatability, and the repeatability is very very accurate. So you keep doing the same operation again and again. These burners come with a very high turn down. They come with a high turn down of, say, 1 is to 5 or 1 is to 6, which directly, if you look at it or if you compare it with a mechanically controlled burner, it would have an impact of about 2 to 2.5% on the overall annual fuel bill of a customer. And on a yearly basis, 2 to 2.5% is a significant thing. This was about oil and gas burners. When you come to biomass, now biomass boilers come with their own challenges. One is there are many fuels that are available. India is a country which is predominantly agricultural country, and we have a lot of agricultural biomass that's available that can be used as fuel into the burner. Now, do we have the same fuels across the country? The answer is no. Every geography, every region has their own set of fuels that come in. Each fuel has their own challenges. Some are easy to burn, some are difficult to burn because the moment you burn them, they will emit certain emissions which are fouling to the boiler. That is one. You have another solid fuel which is coal. Coal was being traditionally used, but with Indian coal not being the right kind of Indian coal grade not being available, customers are more and more dependent on Indonesian coal or imported coal to come in. They also come with their own challenges in terms of variation of the fuel quality, the
Fine.
availability, all of this. So what happens is when you're looking at biomass also there are seasonal variations and all of that. So the technology has to be selected in such a way that it can handle all these variations. There are technologies like a fluidized bed technology or a traveling grade technology that's available, or recently the step grade reciprocating technology that's available. And while the customer selects any of these technologies, he has to look at certain points wherein what am I getting the right flexibility of fuel to, because I have certain set of biomasses available today. These could not be available 5 years down the line. Am I geared up to handle all of those things? One very interesting aspect that happens in industries today are many industries have their own waste generation. Like if you go to a coffee plant, after the coffee filters are made, you have the coffee fiber that is left behind. If you go to a tea factory, you have the tea waste left behind. So on and so forth. There are many industries who are generating their own waste. And what do you do with that apart from landfills? That's also something that can be burnt into the boiler. The customers can explore that as well. And when you select a technology, it has to be looking at these things and not only a 5 year or a 10-year horizon.
So if you look at as few points which I could get from the discussions we had, one of the important aspect of any kind of a combustion technology which is going to be chosen by the energy user is the turndown, because in process industry there is a lot of variation in the load which is expected over a day and over the week and months. What goes for is the turndown, which is one of the important aspect, as you rightly said. And turndown means at the lowest turndown, it should give the right efficiency, which is close to the rated efficiency. Similar way, what I have seen in a combustion technology is that there is a time, temperature, and turbulence, which are the three factors which matter in terms of whether the combustion is happening in an efficient manner. Secondly, there is a clear demarcation in terms of what kind of air to fuel ratio which we need to maintain, what kind of excess air levels which needs to be maintained for complete combustion of the fuel. So on these aspects, are there designs who are actually operating with best of these being taken care of? And how do we know that yes, these are the areas where if you look at, it can help you to get a better combustion efficiency?
I think it's very interesting to look at these aspects. If you look at oil and gas, it's fairly easy to burn these fuels. Because the fuel is standard, the air requirements are standard. You know the variation, all of those loads. I think it's easier to handle when it comes to these fuels. But when you look at solid fuels or any agro-waste biomass fuels, because every fuel is different, there has to be a system which adapts to it, uh, to the requirement of that particular fuel. Like if you take the example of say agro waste briquettes would be low on moisture, but could be made out of fuel which are high on volatiles, or it has an oily nature into it because of the very components. So to take care of all of these, if you look at the biomass combustion, you have to give different processes their time to for the fuel to burn, because it doesn't burn like oil would burn or gas would burn. You have to first evaporate the moisture from the fuel, then the volatiles will start burning, then you have the carbon that gets completely burnt out, and then you have the ash that is getting deposited. Now all of this in the same area, if it has to happen, it will require an excess amount of energy, or it may not be as efficient combustion. So it is important that when you are burning these fuels, you have to have zone wise combustions, wherein you are letting each of these processes to happen into a separate compartment or a separate zone into a combustion system. So that is at the end of it going to deliver the highest combustion efficiency, also going to deliver the highest turn down that is going to happen, and in turn the boiler efficiency or the thermal oil heater efficiency will be at the maximum. So that's these are some points that one has to definitely
So,
look at.
so you are hinting towards the process of combustion for solid
Yeah.
fuel, where
Yes.
there are four stages: drying, the pyrolysis, then there is a fixed carbon burning, and there is a ash burnout, which is separated from the furnace. So you are saying if you have a control in terms of the air to fuel ratio being separately maintained for each of these areas, it can ensure that you can get best of the combustion efficiency. And when you are talking of a combustion efficiency, does it matter to the customer or the energy user? The answer is partially no. Reason being, even if you generate the energy at the best possible, the combustion is happening at the best possible efficiency. What is important is how do you deliver that energy to the water to generate the steam, or to the thermic fluid heater to give the thermic fluid the required temperature. So on that, are there any specific considerations one should look for when it comes to the design of the pressure part, which can actually give the best possible thermal efficiency? Because the combustion efficiency is one part, but the second important aspect is the thermal efficiency, which can reduce on the fuel bills.
So it's always a combination and the balance of the combustion technology as well as the pressure part design that we have to do. And as I earlier spoke, there are fuels which have properties which are fouling in nature, like mustard husk or cashew nut or a soya or cotton stalk, which has inherent oil content into it. Now, when you burn them, they tend to, the flue gases, when they are almost at the exit of the boiler, they tend to drop in temperatures and then they tend to stick there. So any of these actions is going to reduce the overall effective heat transfer area available on the boiler. Now, which will mean that you will have to take the boiler for a shutdown to clean the boilers. Now, one of the very important aspects is when you have a biomass boiler, how do we look at the cleaning frequencies or the overall uptime of the boiler? If you look at out of the 365 days that one would be operating, the closer we are to 365 days, the overall operational efficiencies of the boiler would be much better. But if you look at these fouling fuels, which you may have to take a shutdown every 90 days or 120 days, depending on what is the fuel that is being burned. Now, if every time you take a shutdown and restart it again, it's that much amount of excess fuel that is getting consumed. But as compared to it, if there is a fuel like rice husk or any other fuels which are non-fouling in nature, say sawdust, which could mean that the boiler runs for a much longer time. But that while we have this as one consideration, one also has to look at what is the availability or type of fuel available locally in that area where the plant is. Also, what is the cost of that fuel? I have the choice of buying an expensive fuel, but that is again going to not help me meet my energy requirements. So when I have certain set of fuels that are available, it is very important that the combustion technology, where I spoke about zone-wise combustion, also get matched up with a pressure part design which gives them that longer operation period. So there are boilers which are water tube boilers completely, which are designed and which are made for handling and burning complex fuels, because the cleaning frequencies are much lower there and the availability of the boiler much higher. Versus there are other fuels, other technologies, which is a combination of a water and a smoke tube design, wherein the deposition happens on the smoke tube, so you have to clean it. So the which are not suitable for any of the fouling fuels. So any of these designs, I think it's imperative on the OEMs like us to educate the customer, educate the process user or the end user, to tell them that okay, this is what is available in your area, these are the complexities of each of these fuels, and then try and build a solution around it so that it gives them the maximum output.
So, especially talking on biomass, what I've seen is in a oil and gas fired boilers, normally there are very standardized technologies available. The burner plays the vital role in terms of the combustion efficiency, and burners are more or less standardized on the pressure jet burners. As you rightly said, it has to be electronic compound regulation, which ensures that you get the best of the control in terms of the air to fuel ratio. And there are certain special fuels in oil and gas which can go for a rotary cup burner, which is another design which is available. But if I come to a biomass family of fuels, what I realized is there has been a lot of variations in terms of the technologies. The technology has evolved. It started with a manual fired boilers, it went into a chain grade boilers, that's another technology. Then it entered into a traveling grade boiler. Then it started with a fluidized bed boilers. And then the technology now has come up to a reciprocating or a step grade boilers, which is one of the product which we are also making. So if I look at these evolution of the boilers and the technology is being evolved as the requirements of the process industry needs, what I could get from your discussion is that one of the important criteria for these evolvement was the turndown, which is how I can operate at varying loads of process, the boiler being a good response to the process. And secondly, how I can ensure that each and every parameter of air to fuel ratio, the three T's of combustion, which is time, temperature, turbulence, is taken care of. And I have the right kind of a residence time for the fuel to be there in the boiler. But what matters now is that when we are selecting a particular technology, why do we select that? Like, can we have certain examples where, for example, for Indian coal, what is the best suited technology you feel, in your opinion, and what is that customers feel are the right technologies for Indian coal? Likewise, what is the right technology for biomass briquettes? So, what is your say on that?
So, if we look at various technologies that are available in the market, there are many technologies that have been evolved and developed over the years. Um, One of the technologies remains in the market, which is the fluidized bed technology. Now, every technology that we talk about has its own pros and cons in terms of limitations, and these were developed in line with the fuels that were available then. A fluidized bed technology is used for conventional fuels like Indian coal or imported coal or rice husk, and are mostly designed for baseload operations, where there is not much of a fluctuation of the steam loads or the energy loads on the boiler. But this technology has its limitations in terms of handling a certain size of the fuel, has also a limitations in terms of handling the turn down. So the turn down is anywhere between 50 to 100%, which is it could happen many times that the process load could go much beyond 50% for a certain time, and then again it ramps up to more than that. So all these fluctuations have to get addressed. So there was a limitation in terms of this here. Secondly, with the changes in the biomass that happens, this technology is not geared up to handle every kind of fuel that is available into that particular geography. It has limitation in terms of handling moisture. It cannot go beyond 15%, 20% of the moisture levels of the biomass. It cannot go beyond 8 to 10 of the particle size of the fuel. Also, the amount of fines that are present in the fuel, that it will have its own limitations. So it was imperative that there were alternate technologies that were available. Then we had the traveling rate technology. If you look at both FBC as well as traveling rate technology, both are still not using a zone-wise combustion as I was speaking about, because you have the same chamber where you are fluidizing the bed and the fuel is burning in suspension. Here on a traveling grate, again you have the fuel at one place while the grate travels from one end to the other, and the combustion has to happen. All these four steps of drying, pyrolysis, the carbon and the ash has to happen in the same area where the fuel has been dumped. The most versatile and the flexible technology that's available in the market today is the reciprocating type step grade that is there, which we also offer as solutions to our customers. Now, why do we have this? It's one, very versatile in terms of taking any kind of fuel that's coming there. Secondly, any changes in the fuels over an operation also. So like if you see in biomass, there is no constant quality of fuel that's available. You have one moisture today, a second moisture tomorrow. There is a different level of moisture during the monsoons and dry seasons. It is different. Second, there are issues like fouling. There are issues like traces of oil into it or traces of chlorine into it. So this is a technology which is geared up to handle any of those. So if you see, because of the zone wise combustion, if you see that there is a high moisture fuel coming in, the step grade understands that there is a variation in the fuel quality that has happened. So if it is more oil, more moisture in place, it will push in more fuel and also increase the air circulation so that you have drier fuel available. Now all of this is done automatically into the system without hampering the process demand of the customer. So the boiler keeps catering to the process demands as irrespective of what changes have happened into the fuels. So that's one very important thing. Today we have a certain set of fuels that are available. 5 years down the line, there could be a completely different set of fuels that are available. So this technology is something that gives the customer a long-term flexibility of adapting to any changes that are happening, and at the same time give them the highest efficiencies. When I say efficiencies, the combustion efficiencies are very high, so it gives a overall benefit of close to 2.5 to 3% on the annual fuel bill. You have a large higher uptime of the boiler. These boilers would be available for more than 345 days, 350 days in a year, which will mean that there are no stoppages for cleaning of the boiler, which again gives the benefit of to the customer to about 2.5 3% of operational efficiencies. So I think given this scenario and given the dynamic situation of the biomass scenario that we are into, it's best suited that the customer goes in for a reciprocating step grade technology for all their requirements.
Well understood that for a efficient combustion you need to have the technology which can take care of air to fuel ratio control, the residence time of the fuel. However, parallelly, if I look at it from the point of view of the safety and the emission part of it, because while we are looking for efficiency as one of the criteria for selection of a combustion technology, and also looking at sustainability in terms of having variety of fuels being available and the technology suited for that, how does it pan down in terms of the actual emissions, what it will have, and how safe it is in terms of burning such kind of fuels in a particular technology? So how do you see that as the area where one has to look at in terms of what best can be done on the emission part? Because today if you see globally we are all are looking at looking for a lower emissions, we are looking at lower carbon footprint, and we are looking at much safer operations, knowing that there has to be least manual intervention in the operation of the boiler or any thermocouple heater. So how the step-grade technology can cater to these aspects of emission and the manual intervention? So that part also, if we can,
So I'll take the emissions part first. So if you look at various technologies that are available, when we spoke about the fluidized bed technology, so whatever ash is generated after the fuel is burned, in case of a fluidized bed technology, majority of the ash gets translated as fly ash and goes to the downstream equipment like the heat recovery units or the pollution control equipment. So the dust loading there is very high as compared to any other technologies. So you have a certain higher particulate matter that's available. It's also to be seen that whatever you put in the boiler, it is going to come out irrespective of what technology is there. However, if you look at why a step grade technology, about 70% of the ash gets removed at the grate itself. So thereby it reduces the overall dust loading on the equipment which are downstream, like the heat recovery or the ESPs or the back filters. Uh, and only 30% of that ash translates ahead, which means that by its very design and by its very nature, these boilers are designed to run on lower emissions, and it doesn't impact the environment as directly by having a particulate emissions there. So that's also one of the advantages that one gets by opting for a step grade technology. Coming back to the safeties, it's of paramount importance that any pressure part or any pressure vessel that's operating into a plant is running without any issues or without any safety hazards. Uh, so if you look at it at the end of it, it depends on how much is enough, what is the level of automation that one tends to get into. But there is also a balance that needs to be brought out, that it has to be a completely automated system starting on the safety parts. So if you look at the systems that we have to offer, we give about 160 165 safety interlocks that are there in the boiler, which is continuously getting monitored, and there are no bypasses or manual overrides available for them. If you talk about a draft that has to be maintained, any variation of the fuel that happens, the draft will still be maintained constant. If there is any alarm or any trip that happens, the system is designed to stop or take corrective actions into a safe mode, thereby not creating any unsafe situations when the boilers are operating. So I think, as you rightly said, it's not only the type of fuel that's available or the type of technology one has to select. It's very important that we look at it holistically in terms of the technology, the type of fuel, the challenges that the fuel throws in, the if there are any safety related issues that the fuel brings in, also what are we doing in terms of the emission parameters, and also the overall safety of the entire system. So it has to be a system which is a foolproof system in place, and that's one of the very important criteria where the customers or our industries have to look at it and find a balance and make the selections what are right for them.
So, in conclusion, we can say that while selecting a fuel as a source of energy for any energy plant requirement, one has to look at the geographical location, one has to look at the process demand requirements, one has to look at the cost of fuel, and also the sustainability of the fuel available in that particular market. Additionally, as we are going to have a demanding change in terms of the cost of energy, we should look at the combustion technology selection as one of the major part where one should look at while designing or starting the plant. And combustion technology precisely needs to take care of few aspects like the turnaround which is available, the efficiency at which it is going to operate, how it is going to take care of the emissions, how safe it is in terms of the operation. And if you take care of all these aspects and try and fit a particular energy source like a fuel or a combustion technology, it can help to get the best possible results in terms of lower steam cost as a part of your overall product cost. Hope you enjoyed the conversation. Uh, this podcast will be available on all major streaming platforms. Make sure you subscribe to the podcast as well. Thank you for watching.